All right, so this second video for 2.2, we're going to look at the vertical line test. We're going to look at how do we identify if a graph or an equation represents a function. Um, so the vertical line test just says a curve is the graph of a function if and only if no vertical lines intersect the curve more than once. So this one, it gives an example. X equals a, so this vertical line here only touches the graph once, and we could also see if we draw any other vertical line, it will only cross the graph exactly once. Or, I mean, even possibly if this graph does stop there, then these vertical lines out here would not cross at all, which is also fine. We're just looking to make sure that no vertical line crosses it more than once. So this one is a function. Whereas this one, you can see if you draw this vertical line, it does cross the graph twice. And so this one is not a function. And it's not that every vertical line has to cross it more than once, but if you have any vertical line that crosses more than once, then it's not a function. And this goes with, if you remember from the first section, the definition, so each input gives exactly one output. If there's a vertical line that crosses more than once, you can see we have these two ordered pairs. We have AB and AC are both part of this graph. And in which case, what that means is the input A can give two different outputs depending on where you are. And so that means it's not a function. And that's why the vertical line test works the way it does to decide if it's a function or not. The next way that we can talk about this is looking at equations. So any equation in the variables x and y defines a relationship between these two variables. So relation, if you remember from algebra classes, a relation is any set of ordered pairs. Now the relation may or may not be a function. So in this case, y minus x squared equals 0. That is a relation. There's a relationship between y and x. Is this a function of y, or is y a function of x? So to find out, we solve for y, just rearrange this, get y by itself, we get y equals x squared. And so, yes, this is a function. So we know that y equals x squared is a function. So however we rearrange that, it's still going to be a function of x. What about, does the equation define y as a function of x? So we have y minus x squared equals 2. We can do the same thing, y equals x squared plus 2. Any quadratic function, which this is a quadratic function, is going to be or any quadratic equation, I should say, is going to be a function. So yes, this is a function. What about this one? X squared plus y squared equals 4. So let's solve this one for y. And we'll take the square root. Now remember, when you take the square root and you have a variable involved, you got to do a plus or minus. And so this one would not be a function because when you graph the plus and the minus square root, and we'll talk about what that would do in a later section. When you graph that, it would not pass the vertical line test. So one good way to remember this, at least for a class like this, where we're not getting into super complex functions, anytime that you have the y being squared, it is not going to be a function. The reason being, you could get, so y could be plus or minus, x could be plus or minus, and you kind of interchange the negatives and the positives with these two, and you can get different answers with the same variable, or the same input, I should say. And so that's why it's not going to be a function. But just kind of as a shortcut, if the y is squared, it's not going to be a function. And most likely, if the y is not squared, then it will be a function. I think that's pretty safe to say in this class. It's not 100% foolproof rule for all of math, but generally speaking, if the y is squared, it's not going to be a function. And if the y is not squared, it will be a function. So then we'll have we just have some basic graphs. We talked about some of these. So we have the constant function. This would be y equals b. In this case, b is some number, whatever number it is. That's a horizontal line. Here we have the linear function y equals mx plus b. If this m is negative, then it looks like that. We have the quadratic. We have the cubic. Here we have the quartic x to the fourth. Here we have the quintic x to the fifth. Now notice x squared and x to the fourth look pretty similar. The main difference is it kind of flattens out here on the x to the fourth. Here it's not so flat. And the higher, as long as that exponent is even, it's going to have this basic shape. And then the higher the number is, higher the exponent is, the flatter this will be. So if you got x to the 10th, for instance, this would still be the same shape, but it'd probably be skinnier up here, and then it'd be flatter down here. And then same thing with x cubed and x to the fifth. These had the same basic shapes, but again, this one gets flatter as we get close to the origin. This one does not get so flat, kind of keeps going. And same thing with, as the exponent gets bigger, as long as it's odd, it's going to have the same shape, but it will get flatter and get taller faster. Then we have some root functions. So here we have the square root of x. We talked about that one. Here we have the cube root of x. And notice the cube root goes on the negative because you can take a negative of a cube root. So it's almost like the square root. It's very similar there. And then it just kind of reflects around the origin. It looks like that. And again, if we go to the fourth root, it looks a lot like the square root, but it kind of gets taller faster and then slows down after that. Same thing here. This fifth root of x, like the cube root of x, looks the same, but we kind of have a steeper part here around 0. Then we have reciprocal functions. So these are functions that are 1 over x to some exponent. So 1 over x looks like this. 1 over x squared, we have on both positive, because of course, when you square the x, it's always going to be positive. 1 over a positive number, it's going to be positive. 1 over x cubed, again, notice 1 over x and 1 over x cubed look similar. 1 over x squared, 1 over x to the fourth looks similar. So, so these are the kind of patterns that you need to pay attention to. And that will help when we start graphing these and want to shift them around and flip them upside down, that kind of thing. The last one, I don't think we're really going to talk about the greatest integer function, so we won't bother with that one here. If it comes up later, we'll look at it. But absolute value function, this one just looks like a v. This is basically taking y equals x, and then when x is negative, it's going to be y equals negative x. So this is kind of like a piecewise function where you have negative x and you have x. It is negative x when x is less than 0, and it is just y equals x when x is greater than or equal to 0. So those are your basic graphs, and make sure that you have these shapes memorized. If I ask you what x to the third looks like, or x squared, or square root of x, or any of these, then you should probably be able to know what those look like pretty easily, and then that makes things easier later in the course once we get into a little bit more complicated things. But if you have any questions, feel free to email me or post in the discussion board with the questions there.